Today we're moving on and we're going to be covering standard deviations. So in univariate, we're going to go over standard deviation. Standard deviations are also known as normal distributions. With our normal distributions, it's going to look kind of like a curve. So I'm going to draw the curve. With the line underneath. In our normal distribution curve, there's one line in the middle that stands for the mean. Remember, x with the bar on top of it stands for the mean, so x with the bar equals the mean. This little symbol here is called the standard deviation. In our normal distribution curve, we have the mean in the middle, and then there's 3 lines to the left and 3 lines to the right. Each line represents another standard deviation. So I'm going to turn my paper and we're just going to fill in over here. The numbers to the left are smaller, so it's the mean minus 1 standard deviation is the first line. I'll zoom in because I know I'm writing a little bit tiny. Okay. Remember to pause the video whenever you need to catch up. Then we have the mean minus 2 standard deviations. And then we have the mean minus 3 standard deviations. So going to the left, we subtract. Going to the right, we're going to add. So if this is the mean, we're now going to have the mean plus 1 standard deviation. Then the mean plus 2 standard deviations, and the mean plus 3 standard deviations. Each curve of the normal distribution curve represents a specific amount. Okay, so in between these first 2 lines, between 1 standard deviation to the left and 1 standard deviation to the right, this represents 68% of the data. So 68% of the data is between 1 standard deviation away from the mean. So 1 box to the left and 1 box to the right. 2 standard deviations away, so 2 boxes to the left and 2 boxes to the right, represents 95% of the data. And then 3 standard deviations, 68, 95, this one's 99.7% of the data. This is known, okay, these 3 numbers, the 68, 95, 99.7 is known as the 68, 95, 99.7 rule. You're going to see in the directions it's going to say using the 68, 95, 99.7 rule, answer the following questions. So these percentages will be given to you on your quiz, so you don't have to memorize them, but it's going to make your life a ton easier if you actually do have them memorized. Now what we're going to do before we move on to an actual question where we use the normal distribution curve and the mean and standard deviation, we know how much each of these boxes are worth inside here. What we need to do is figure out how much is each box worth individually. So like how much is this box specifically, or this box specifically, or this one. Now if we look, these 2 boxes here, the 2 boxes in the middle in yellow, The first two boxes here is equal to 68% of the data. So if both of these boxes is 68%, then one box is going to be 34%, because I could just divide that by 2, and that means that this is 34 and this is 34, so together it equals 68. I can do the same thing for the next one. From here to here is 95, but I already know that all of this is 68. So what I want to do there to figure out how much is each of those little boxes is I'm going to take the 95 and I'm going to subtract the 68 that's already here, because I already know this much. I don't need that much. So I just need the 95 minus that 68. That gives me 27. So now I need to figure out how much on each side. So I divide it by 2, and that gives me 13.5. So 13.5 here, and 13.5 here. And then here, our last one, 99.7 minus the 95, because we already know all that for the 95. So we'll do the same thing. 99.7 minus 95 gives us 4.7. And we divide it by 2 to figure out for each box, and we get 2.35. Now, the whole entire normal distribution curve is equal to 100%. So I need to figure out how much these two little tails are, and I know that the whole thing is 100%, so I'm going to do 100 minus the 99.7 and divide it by 2, and I get 0.15. So that means 0.15 here, 0.15 here. So this is how much is all around our normal distribution curve and how much each box is worth. So now what we're going to do is an example where we have to create a normal distribution curve and then answer some questions about it. Okay. So example 1, our mean, which is also that x with the bar on top of it, is equal to 80. Our standard deviation, and I'm going to abbreviate that, which we know is this symbol here, is 2. So I want to create the normal distribution curve for this information. Mean's going to go right in the middle. Our mean is 80. We know we're going to have 3 lines to the left and 3 lines to the right. Now, with the standard deviation, remember what we wrote up here. On the left, we're subtracting the standard deviation. On the right, we are adding the standard deviation. So from the mean, we're going to subtract our standard deviation and fill in the numbers to the left. So 80 minus 2 is 78. Now we're going to continue on and we'll subtract that standard deviation again. 78 minus 2, 76. Then we'll do it again. 76 minus 2, 74. Now that's how we fill in the numbers to the left by subtracting. So to fill in the numbers to the right, we add 80 plus 2, 82. 82 plus 2, 84. 84 plus 2, 86. So now we're going to answer our questions. First question says, where does 68% of the data lie? %, if we look back up to our table above in our normal distribution curve, 68% is always between one standard deviation from the mean. So one box to the left and one box to the right. So here's our mean. So one box to the left and one box to the right is between these two numbers. Those two numbers are 78 and 82. So where does 68% lie? From 78 to 82. Okay, that's our 68%. Question B says, where does 95% of the data lie? So if we look at our normal distribution curve up here, 95% is 2 standard deviations away, so 2 boxes to the left and 2 boxes to the right, so that takes us 76 to 84. Questions can be stated like this, or they can be backwards. What percent is between 80 and 84? Oops, sorry. Sorry about that. What percent is between 80 and 84? So in order for us to figure this one out, okay, we need to look a little differently here, because 80 is right here, 84 is right here. So I want to know what percent is right here. So this is where the numbers on the outside of the curve are going to come into handy when they're asking for what percent between two numbers that aren't 68, 95, or 99.7. Because we've already found the numbers up here at the top, I could just copy these numbers down here, 34 and 13.5. These numbers around the normal distribution curve will always be the same no matter what. These percentages that I have here in yellow, pink, green, and black, they're always going to be the same no matter what numbers are underneath here. The only numbers that are changed are the ones at the bottom. So to find out the percent between 80 and 84, I'm going to take that 34, add it to the 13.5, and that's going to give me my percentage. Okay, so that'll be 47.5%. And here you would leave it as 0.5 because that 0.5 is important. With our normal distribution, we have to say one more thing, okay? When we're talking about standard deviations is how far away from the average number, okay, from the mean. So if we're talking about two classes of data, let's say from a test, and we have a test that we had, the average was an 80 with a standard deviation of 5, which means that most people got between a 75 and an 85. I think, did I say 80? Yeah. Okay, so if we have a mean of an 80 and a standard deviation of 5, then we have between a 75 and an 85 for that test. If I had a test score of a 70 and a standard deviation of 10, that means that most of the people got between a 60 and an 80. And in this case, it is better to have a standard deviation that is smaller because that means more people are within a smaller range. So it's always better to have a smaller standard deviation. So it is better to have a smaller standard deviation. So if a question ever asked, oh, which situation would be better, this one with a small standard deviation or this one with a large standard deviation, we would always choose the one that has a smaller standard deviation.